Okay, we've got 3 questions here. We are on our, I don't know, 7th page of these things. I forget which question number we're at on our actual assignment right now, but I'm sure you know. A road increases 10 meters in altitude for every 300 meters of its horizontal distance. That means you go 300 meters this way, and you have climbed up 10 meters, and you're actually driving along this surface here. This is where you're, I don't know, here you go, you're in a car. To the nearest tenth of a degree, what is the angle of inclination of the road? So we're dealing with something like this. We know our sides are 10 meters and 300 meters, and we want to know our angle. So this is our opposite, and this is our adjacent side. So we're dealing with tan. Here we're looking for the angle, and the way we're going to do that is we're going to say the angle is equal to the inverse tan. We've got to undo that bit of opposite over adjacent. So we undo that tan, we throw in the opposite value, 10, we plug in the adjacent value, 300. We can see that meters and meters is going to go out of the way real nice. And 10 over 300 is 0.03333333. And if we take the inverse tan of that, we're going to get 1.909 degrees. And this is to the nearest tenth of a degree, so we would just write in 1.9. We're not going to type degrees because how are you going to do that? Well, I mean, it's possible, but don't bother. 1.9. Next, Vincent is sitting in a tree so that his eyes are 4.2 meters above the ground, which is 13.7 feet. We want meters in the end here. Okay, I don't care about feet. He looks down at an angle of depression of 55 degrees. So let's just make a triangle here. So here is his eyeballs. I don't care where the rest of him is. Here's his eyeball right there. Give it some eyelashes. This is 4.2 meters up. He looks down at an angle of depression of 55 degrees. So that means if he was looking straight to the horizon, that'd be flat, but instead he's coming down by 55 degrees. He sees his cell phone on the grass. What distance from the base of the tree is his cell phone? So we're looking for this side right here. So if this is 55 degrees, then we know what the other angle here must be. If this is 55 degrees, these two need to add up to 90. Didn't mean to get rid of that line there. These two need to add up to 90. So for this angle, our missing angle, I'm going to take 90, subtract the 55, and 90 minus 55 had better be 45. No, it's 35. Don't worry. I can know some numbers sometimes. 35 degrees. So 35 degrees inside here. This angle here is 35 degrees. And I want to know this side. So this is my opposite and my adjacent. I'll use tan. I am looking for the opposite side, so I'll multiply both sides by A. And when I do that by A and by A, this side cancels out, that side doesn't. So my opposite side here is A adjacent times tan of theta. My adjacent is 4.2 meters times the tan of 35 degrees. 35 degrees tan is 0.7. And if I multiply that by 4.2, I get 2.94 meters. To the nearest tenth of a meter, I would write in here 2.9. Probably it just wants you to type in 2.9, but if you type in 2.9 meters, then of course I'll mark that right. If we did this an alternate way. There's another way to solve this problem. Gets us the same answer. And that way is to draw basically a rectangle here. This is supposed to be a rectangle. No, it's not in my drawing, but it's supposed to be. So that this side and this side are the same, these two are the same. It's a rectangle. So in that case, we would know this side is 55 degrees, this angle that they told us initially, our angle of depression. And we would be looking for this side here, and we would know that this is, because these two are parallel, also 4.2 meters up. And in that case, we would be using opposite over adjacent with 55. In this case, opposite would be 4.2. And we're searching for adjacent. So we would take the opposite side, 4.2, divided by the tan of 55. And you can work this out yourself. But if we do that, we still find that this distance is 2.94 meters. Both of those approaches are just fine. So here we would say tan theta is opposite over adjacent, and I'm looking for my adjacent, which is equal to my opposite side over tan, and if you plug in those values, you'll get 2.94, just the same. Last one on this page, Alasha is flying a kite in a field. She lets out 50 meters of kite string, which makes an angle of 70 degrees with the ground. So we've got a kite being flown at way up in the sky. So this angle here is 70 degrees. Suppose the sun is shining directly down on the kite. So we've got the sun up here somewhere shining down. And that makes the shadow of this, so here's the kite. And the shadow of this kite is going to be right down here on the ground. Try to draw a little kitey kind of shadow. There, it's beautiful. Not counting her height. Okay. What is the height of the kite above the ground to the nearest whole meter? So I want to know how high the kite is in the air. She's let out 50 meters of string, and between her, I guess she's like laying down on the ground and flying a kite. I guess she'd have to be positioned differently so that her hands would be at the base of this triangle. Okay, her hands are here. And her head is, I don't know, there. Her feet are there. Sure. She's lying on the ground. She's holding this kite. 50 meters of string. That's here. Kite's up here in the air. And we want to know that. So we know the hypotenuse. And for her, this is going to be the opposite side. With opposite and hypotenuse, that's going to be sine. And we want to know O. Opposite here, we would multiply both sides by h, cancel these guys out, and the hypotenuse is 50 meters times sine of 70. And sine of 70 is 0.9396, etc. If I multiply that by 50, I'm going to get 46.9846, etc. meters for my opposite side. So that's right here. This is my 46.98 meters from here down to there. So the height about the kite above the ground to the nearest whole meter, 46.98 is basically 47 meters. So that's what I would type in there. Although I think you probably just type in 47. I don't know. These things are always a pain. But it's okay. I'll mark them by hand. Next video. Next page.